Hi all internet, these are Java videos from Tech Skills for You, and this video is on stack area of the JVM and the stack overflow error. So let's see the dependency between both. In the last session or else in the last video of my playlist, we have seen an example program which throws this stack overflow error. So I have a method here add which calls itself. So on line 15 if you can see it is calling itself. So this falls into a recursion and it will throw a stack overflow error. So let me quickly run this and show you that error. Okay, so this is my error console, so I could see all the logs here, so I'll just scroll up. So if you see there, so there is a stack overflow error. So as soon as you see there is an error here, right? So what is an error? So in Java, exceptions are mainly because of the programmatical logical or else these functional issues, right? Whereas these errors, right, errors are errors occur because of the lack of memory, okay, lack of resources. Okay, so when I say that it's only because of lack of resources, it doesn't mean that it's not because of the program, right? So if a program is not using the resources in a proper way, okay, it has to use that resources in a proper way so that there won't be any memory issues, right? So here we are trying to fall into a recursion and we are just trying to get that into an error, right? So how to resolve all these things? So first of all, to understand this, right, we need to understand what the stack area of your memory is, or else what is the stack area of your JVM is, and then let's come back to this program again. So first let me open the JVM architecture. Okay, so this is the JVM architecture. So I'm just opening the first link that I got. Okay, so this is the a sample JVM architecture. So here you could see many areas here, right? So there is a class loader system, there is a method area, there is a heap, and we have what here? JVM language stacks. So this is what we call as what? The stack area of your JVM. Okay, so I'm not concerned with all the other areas here. My point of concentration is what? The stack area. Okay, so stack area. So what happens? So when we run the program, right, all the methods or else all the method executions will go into stack area. So in the stack area, all the method calls will happen. And if there are n number of method calls continuously, and if there is no memory in the stack for the next method call, what happens? It gets overflown and it will throw a stack overflow error. Okay, to understand this more clearly, right, so I have just written a small program sample test using which I'll try to explain you how the stack area of your memory will work. Okay, so here is a sample test program. So it is a simple program which it has sorry four methods: a print sum, add, validate. Okay, so what I'm trying to do is I'm trying to add two numbers and print the sum of the two numbers here. So this print sum will print the sum of two numbers, this add will add the two numbers. Here validate, it won't do anything, it is just a placeholder, and from which I'm routing it to the add method. Okay, so here I'm just calling the validate, and as you know, this is main method, the starting of your any Java program. So when I run this, right, what will happen? So to explain that, right, so I'll just open a screenshot that I have already prepared. Okay, so this is what happens. So this is the method, right? This is the class that you are trying to run. So this is the class, right? Sample test. So when I start this Java program add method, right? Start Java add functionality method, right? So even as soon as I start this program, what happens? Main method gets called, right? And this main method will call what? The validate method. This will call what? Add method, and again there is a call to print result or else print sum finally, and the cursor comes back to what? Main method, and the program will end. This is the sequence of the execution, right? That's good. But what will happen in the memory? So to explain that, let me run this program in debug mode. So I'll put all the debug points here. Okay, so I'm just trying to put the debug point in every method of my program. Okay, and I'll try to run this in debug mode. To run this in debug mode, try to just press F1. That will debug your program. Okay, so click on yes so that it will open in the debug perspective. So as soon as I have started this program, you can see that there is a program started with application name what, sample test, in the debug perspective. Right, see here in the debug there is a Java application started with name what, sample test. So as soon as I have started, there is a thread that I have started, right? There is a single flow which is started from the main method. So in that flow, what is the starting point of execution? The main method is the starting point of execution. So the cursor entered into this method, and if you see, there is a thread which has started. So what is a thread? A thread is a single sequential flow of execution, right? So a flow has started here, and thread is named as what? The main thread. If you see, there is a main behind it. It's the name of the thread. Okay. So where is it now? So if you click on this, right, sample test.main. So it's saying that there is a main method in sample test here. So there is a main method in sample test here. So when I try to do an F6, right, what happens? It enters the next method, add, sorry, validate, right? See, in the thread, right, there is a main which is placed at the bottom of the stack, and on top of it there is a validate method. So if I click on validate, what happens? You can see all these memory that is occupied by the main method, right? In the validate method. So in the validate you have two numbers, first num and second num. So first num has 24 and second number has 13 in it. Yes or not? So when we start this program, right, so it's means I mean these methods, right, all these methods are occupying some memory in the stack, right, or else in the, this is the stack, right? So this is the first method that's called in the stack, and this is the second method. And if I do F6, it goes into add method. So there is a stack, right, 1 2 and 3. So all these are laid one upon the another, and when I do an F6, it finally went to print sum, and there is a stack which gets created. So what happens internally in the memory? So let me open that and show you. Okay, okay, this is my screenshot. Okay, let me explain what happens that internally in the memory. Are you ready? Okay, so I think I am done with this video. So if you want to know what happens in the memory, please watch my next video. If you like the video, please do subscribe. Thank you.